Predecessor, please.
Equal to the IG gradient G plus reaction rate of each component. And of course, there should be added state equation for which equation between pressure, density, and temperature. Whereas this one is a mixture weight, but in fact it's mass more mass of 1 mole of mixture. Right? I mean it is 4. Okay. Why I am writing all of these equations maybe more in detail? Because all CFD simulation based on these equations. All of them is the mathematical description of some experimental laws. This one, as I told, mass conservation laws. This one is momentum conservation laws. This one is energy conservation laws. And that one is component conservation laws. And if you are considering some problems with our initial data and boundary conditions, you can formulate this problem in mathematical means. In this case, if you know how you can solve this system of equations in proper way and with enough good accuracy, you can predict this problem. You can say something about what happens if you will change some parameters which are controlling of this problem, and so on. And now, in my lecture, I will try to show you some examples of using of this system of equations or mathematical modeling, and to show you some opportunities of computational fluid dynamics technique. Okay, so now I'll show you I'll begin from the case when we are considering so-called very low Reynolds number. Reynolds number is one of the very important criteria of fluid mechanics, which are controlling is the inertial forces is important compared to viscous forces or not. And it looks like times of some characteristic velocity of flow multiplied to some characteristic length of flow divided by kinematic coefficient of viscosity. And if velocity of the flow is very slow and the viscosity is high enough, in this case the Reynolds number may be about 1, even less. One of the good and very known examples when the Reynolds number is low is the filtration flow in porous media. For example, when you are considering the oil extraction or gas extraction, all the time you will have problems which can be simulated by using or taking into account that this is a filtration problem. So I will show you one of these like these problems. which connected also with filtration problems. But it's not oil or gas extraction. It is about uranium extraction. And we problem is Kazakhstan, one of the biggest producers of uranium now. In Kazakhstan, about 15 to 25% of the old uranium deposits, and all of this, right now Kazakhstan is in this year getting first in the world on the extraction of uranium. For example, about 12,000 tons in this year will be extracted in Kazakhstan national company Kazatomprom. And all of this uranium extracted by so-called underground leaching method. What is the idea of this method? Unfortunately there is didn't show. I could find by this one here, but I will try to show you very. It's this one? Okay. No, I will write some, I will make some pictures, yeah. If in the Kazakhstan all of these minerals of, uranium in solid phase lying on the lines about from 50 to 700 meters, and the concentration of these minerals at this line is very low. You know that there is at least 3 ways to extract of the like these minerals. One of them is building by mining, but in this case concentration of this mineral should be high enough to get to use this way. Other one, if your minerals lies very close to the surface like this, in this case you can use open methods. And other ways, if it lies deep enough and concentration of these minerals is very low, in this case you can use underground leaching method. Idea of this method is you have to put here few wells, depending on the size of your mineral area. For example, in planets maybe looks like that, and there is one well. It is, we are calling pumping well, this one, and the other wells should be here. From these wells we have to pump some solutions to solute minerals in this layer, and getting these minerals in liquid phase. After that we have to pumping out, can you say? Pumping out through these wells. This is pumping wells, this is extracting wells. In fact, if mineral size, size of the mineral where the deposits is large enough, for example, usually it's